All right, we have a few key points for lesson 3A here. We're starting with 3-1 reflections. A reflection is a flip of a figure. The term this book uses is in a line. I've also seen the term across a line. And this is any time that I have a figure, and it could be as simple as a triangle, and then some line that I'm going to reflect it across. For instance, if this were a mountain, and this is a lake, then I might see the reflection of the mountain like this. This would be a reflection across the lake. In this case, this is a reflection across the x-axis, or in the x-axis. Okay, the line the figure is flipped across is called the line of reflection. In class, we explored with the x-axis and y-axis, but we'll find we can also reflect across other images. And reflection is a type of transformation. In any transformation, we have a pre-image, the initial point, which we label like A, B, C, and so forth. And the image, the transformed or after point. So this might be A prime, this apostrophe we read as prime, B prime, and C prime. And when we reflect, we'll find that the pre-image, that's our ABC, and the image, our A prime, B prime, C prime, are going to end up being the same distance from the line of reflection. So these two distances will be the same. This distance and this distance will be the same to each other, and these two distances will be equal to each other, which means that this line of reflection acts as a perpendicular bisector. Remember, we measure distances as perpendicular to the line, and so that line acts as a perpendicular bisector. So if, for instance, we wanted to construct a reflection, we don't have specific coordinates, we just want to construct a reflection, then we're going to do our best. If we had a ruler, we can measure this and say, okay, this is the distance for C, and I'm going to continue straight and try to measure off that same distance here. That's my C prime. Here's my distance for B. So I'm going to try to go that same distance here. Here is my B prime. Here's my distance for D. I'm going to go that same distance here, and that's my D prime. And this is my A. I'll try to go that same distance here, and that is my A prime. And then I could connect those points. We had a C connected to D, connected to A, connected to B, connected to C, and I have drawn my reflection. These should also be right angles, perpendicular, and then this and this should be equal segment measures. These should be equal. These should be equal, and 1, 2, 3, 4, 1, 2, 3, 4 will be equal. Then we have reflections in the coordinate plane. We did quite a bit of this in class. Flip that over there. Okay. To reflect a point in the x-axis, we found we multiplied its y-coordinate by -1. To reflect a point in the y-axis, we multiplied its x-coordinate by -1. And then this is a new one. If we were to reflect a point across the line xy, so here's my line xy, and if I had a point, say 1, 2, 3, 2, if I were to reflect it across this point, across this line, I would find, and this is a little bit off, that if the coordinates had been 3, 2, the new coordinates would be 2, 3. So my x and y values would exchange. And we can write this in our short form. Spread these out a little. Oops. Oh. Here we go. In our short form, and this is the form I recommend having in your notes. Okay. To reflect across the x-axis, I change my y sign. To reflect across the y-axis, I change my x sign. To reflect across y equals x, I exchange y and x. And we'll come back to this last one in a moment. So with these three, when I'm asked to reflect this quadrilateral, and this is our quadrilateral, when I'm asked to reflect this quadrilateral across x equals 0, or if I looked at a coordinate plane, x equals 0 at the y-axis. Okay, so at the y-axis, x equals 0, so this is saying reflect across the y-axis. I look at my y-axis rule, and I take each point, so my original D, E, F, and G, okay, was -2, 3, E was 4, 4, F was 3, -2, and G was -3, -1. Then my D prime, E prime, F prime, and G prime, I'm going to change the sign of x, keep the y, for a reflection across the y-axis. So change the sign of x, keep the y. 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 And that's it. Now, it's slightly more complicated when I have some other y equals or x equals line. We'll go into the details in class if we didn't in the lab previously. But instead of just changing the sign of y or x, we also need to multiply 2 times whatever that line is. So in this case, number 4, y equals 1, that means we're going to use this format. We're going to keep x the same. We're going to change the y sign and add 2 times 1 for our image. So my original points were -2, 3, 4, 4, 3, -2, -3, -1. Move this up a little. There we go. This was my original xy. And my D prime, E prime, F prime, and G prime. My x's stay the same. Let's just list those all down. 4, 3, -3. And for my y's, I'm going to change the sign of y and then add 2 times 1 or add 2. So 3 changed as -3 plus 2 is -1. 4 changed as -4 plus 2 is -2. -2 changed as +2 plus 2 is 4. -1 changed as 1 plus 2 is 3. And that's how we can apply our rule to find the coordinates of an image. All right? And then we have translations. Oop, my example got messed up. Move that down. Here we go. All right, so with translations, this is a transformation that moves all points of a figure the same distance in the same direction. Okay, and we describe that direction and distance in terms of, typically in terms of x and y values, but we can also describe those just with an arrow. And what we find is when we create a translation, the segments connecting a pre-image and image for each point, those form the same slopes. So for example, C, there we go. Move that down just a little bit. All right, for example, C, I want to move, what I'm going to do here is draw a line that I can move. Okay, so I've created this line, and I want to use this as a guide to create my new points. This is I prime, and then I'm going to grab, see if I can grab this line and line it up here. And you could use a ruler, you can use a sheet of paper. This is now my J prime. And then I'm going to grab this again. Oops. And line it up here. This is my G prime. So I put the dot at the end of the line and then label it. And put that there. And that's my H prime. Okay? And if I connect these, then I create a translated figure that's been moved to the right and up some amount. Okay. Then we can also indicate these with a vector. So this is a specific x and y value, a value added to x, a value added to y, written in the form with these little pointed brackets, a comma b. These are vector brackets. And we translate vectors with the rule, if I'm translating point xy by some value ab, then my new values are going to be x plus whatever a was, b plus whatever y was. Just pretty straightforward. So we have this quadrilateral. T is -3, -8. U is -6, 3. V is 0, 3. And W is 3, 0. This is my xy. And so my new value, when I'm translating by 4, 5, is going to be that initial x plus 4 and that initial y plus 5. So T prime, U prime, V prime, and W prime. My new T value is going to be -3 plus 4 is 1. My new U, my x coordinate for U will be -6 plus 4 is -2. 0 plus 4 is 4. 3 plus 4 is 7. My new y values, -8 plus 5 is -3. 3 plus 5 is 8. 3 plus 5 is 8 again. And 0 plus 5 is 5. So these are my image coordinates. For an image that has been shifted, this would be to the right 4. 1, 2, 3, 4. And up 5. 1, 2, 3, 4, 5, which means each point goes up at a slope of 5 over 4. And that's it.